What's up, everybody, and welcome to the second episode of Deconstructed. In the last episode, we started off our new Super Mario Bros. Mechanics, which included 2.5D, the follow camera, and the hat. On this episode, we're going to be adding the twirl. So the first thing I did was go into my event graph and then add a twirl event. Now the plan was going to be to use a timeline to lerp the twirl from a starting rotation to an ending rotation. So I quickly created a timeline and then named it Twirl Timeline. Timelines are a quick and easy way to lerp from one value to another. You can create a track and then play it from the start and then use the value of it as it plays to update a certain variable. You can also add curves to it, which is pretty neat. I created a float track and added the values from 0 to 1, 0 being no twirl and 1 being a complete full rotation or twirl. And I set the time from 0 to 3 seconds as a start. I also added a little curve to the track because I wanted the twirl to start to speed up towards the end. Next, I created a variable to store the rotation before the twirl occurs so that it can add on to that preset rotation. This is because if I just tried to add to the current rotation, it would continuously add and just keep spinning forever and ever. So this grabs the rotation at the time the user uses the twirl move and then adds onto that value, which stays static because it grabs it from that moment. I then grab a multiply node, which I'll be multiplying the twirl alpha by 360. So basically, as the twirl alpha plays and gets closer from 0 to 1, the output value of the multiplication node gets closer to 360, and I'll then add that to the rotation and set that as the active rotation, subsequently getting it closer and closer to a full rotation. Another note is I decided to add the rotation value instead of just setting directly because rotation values are repeated since they are on a circle, and it would be better to add to ensure that it continues in the same direction properly. I then get the active rotation and then set that value to the pre-twirl rotation, which will be stored and then used to set the new rotation during the twirl. I then add that to the stored pre-twirl rotation. I then grab a set active rotation node and plug in the new rotation along the z-axis and the old rotations along the x and y axis since I don't want to change those. Here I just used a temporary input action that I used to call the twirl event. Here's what I had at first. It was rotating, but you couldn't see it because I was setting the rotation to a full rotation without interpolating it. So to fix that, I grabbed a rInterp2 node and plugged my pre-twirl rotations into the current rotations, and then grab the pre-twirl rotation to the X and Y, plug that into the target rotation, and then plug the new Z rotation into the target Z rotation. I then got the world delta seconds as the delta time. And for the interp speed, I started off with 15, but I ended up changing it around and going higher and higher. As you can see by the text in the top left, the twirl was working but extremely slow, so to fix this I went back and I played with the timeline length, made it shorter, and I also increased the interp speed. Here's what it looked like when I found the values that I thought were good. But now I had to account for the cooldown, because in the moment you can twirl as many times as you want, but in the game you actually have a few seconds before you can twirl again after you twirled the first time. So to do that, I created a Boolean variable and I called it isTwirling. Basically, the variable functions as a checker that checks if you have twirled recently. So to implement this, at the beginning of the twirl event, I check if you haven't twirled recently. And at the very beginning of the twirl event, I'll set it to true so that you can't twirl again. And then when everything is finished, I'll add a delay node for however long I want the cooldown to be and set it back to false. I just went ahead and used 0.5 as the cooldown value. Now it's hard to see here, but I'm hitting the twirl button multiple times and it's not letting me do it back to back to back. Now if I were falling like in the clip, it would let me, but it would give me a cooldown, of course. Now, to prevent the front facing event and the twirling event from colliding, since they both handle the actor's rotation, I quickly implement the isTwirling boolean into the logic for the prevent front facing. This ensures that it doesn't try to force the rotation in any direction while the player is twirling. And then here I just quickly organize all my pins, make them look neater. Now there's another twirl variant I had to account for, and it was twirling off the ground. It kind of acts as a jump, but it adds more velocity in the Z direction than a jump would. So my plan to handle this was to check if the character was falling, which subsequently checks if the character had jumped, and if they aren't, I would launch the character in the Z direction. I started off with 1000 as my test value, but I eventually end up coming back to change this. This is what twirling from the ground looked like at the moment. It was way too high for my liking. And here I'm just going through and testing some other values until I find the sweet spot. Now I kind of felt like I made the jump power too high, so I went back in the character movement component and then reduced the jump power, but I also had to make sure it was less than the twirl jump. So here's a direct comparison of just jumping and twirling and jump. As you can see, the twirl does add a bit more velocity in the Z direction. Now I went back and I changed the 360, I multiplied the alpha by to a variable. That's because when twirling off the ground, the character actually spins more than once, and I wanted to be able to change that dynamically. So I set it as a float variable, which I would be changing at the beginning of the twirl event. So basically, to implement this variable, I checked if the character was falling or subsequently jumping, and If they weren't, then I would set that value to 720 so that the character rotates twice instead of once. And if they are, I'll just set it to 360, which is the base value. Here's twirling off the ground. Here's jumping twirling. As you can see, there's a slight difference between the two. However, I felt like it got a bit too fast at the end, so I removed the curve from the timeline and just made it linear, just to keep it at a constant speed. And here's what it looks like after. Now, I had the twirl implemented, but I wanted to add an animation. So to do that, I created a level sequence that I'll be using to animate the starter mannequin. I called the level sequence animation maker because it'll be what I'll use to make some simple animations, maybe in the future. So I went into the starter content folder and grabbed one of the mannequins animations, the idle animation, as reference for my twirl animation. I then added that to the sequence and it was time to animate. To do this, I just simply raised the arms in a T-pose and saved this as a animation asset. I then went to the Manny's animation blueprint, which is the parent of Mannequin's animation blueprint, and I added a reference to the character or the third person character's actor and set the variable to a variable that will be updated inside the animation blueprint. So I just kind of matched their names and set the isTwirling variable to an isTwirling variable inside the animation blueprint so that they're matching at any given moment. Then I went to the states and added a twirl state. Now I wanted to be able to go from twirling to falling and from jumping to twirling, so I connected the transitions as followed. I then went into the twirl state and added the animation that I just created. I then went into the transitions and added the conditions in which they can transition. So from jumping to twirling, I used the isTwirling, and from twirling to falling, I used isTwirling but added a not boolean. So when the user is not twirling, it'll play the fall animation. Now this worked pretty well, but there's an issue because of the cooldown. Since the cooldown had a delay before setting the twirl variable back to false, the user would be falling while playing the twirl animation just for a split second, and it kind of gave a T-pose look. So to fix that, I went back into the blueprint. I renamed the original variable isTwirling to has twirled recently, and I created a new variable for isTwirling. Basically, the difference between the two is that has twirled recently is used more as a cooldown, and isTwirling is more like an is falling kind of node, which checks if the user is actively twirling. I then set the isTwirling variable to true immediately after the twirl event is called, and set it to false immediately after the twirl event is finished and not after the delay. So no cooldown, like I said, once again. I went back to the blueprint and the animation blueprint, and I swapped out the variables so that I got the proper isTwirling variable. And voila, as you can see, we don't have to suffer from the problem of it kind of falling and twirling at the same time. Here's the final product, and here's it compared to the new Super Mario Bros. Twirl. Here I just went back and organized all my blueprint nodes, as well as add a comment to the blueprint setup. Now I wanted to remove the temporary left mouse button and add a proper input, so I quickly went back and did that. I started by adding a input action and called it Twirl. I then went inside my mappings and added the Twirl action and set it to the same key, which was the left mouse button that I used earlier, but this time I can use the mapping instead of just a instant action call from a key binding. Then I simply just called the control from the mapping and then connected it to the Twirl event that I just created. Now everything was working, but I had one issue. Whenever I repeatedly pressed the Twirl button, it started to do the T-pose thing once again. This was because I was trying to transition back into the Twirl while it was falling. So to fix this, I removed the has twirled recently condition from the Twirl event and added it to the actual mapping event. That way, it doesn't even attempt to twirl unless it hasn't twirled recently. So it doesn't even accept the key unless it hasn't twirled recently. And as you can see, this fixed the issue, and this is the actual final product. Thanks for watching, like and subscribe.